Hello, friends. What we have here now are the solutions to open-ended question 4 or free response question 4 from the 2025 AP Physics C mechanics test. The first question, so we've got uh, two objects, a disk and a ring, and they're both rolling towards the same ramp, and they're going to roll up the ramp. Same material, same mass, same radius, all those things. And so they tell you that the ring goes higher up the ramp than the disk does. So they want to know which of these has or they ask you to compare the force of static friction with between the two of them. Now, one thought I had as I was thinking about this was, oh, it's going to be the same because it's just the normal force times the coefficient of kinetic friction, and it's the same mass, same radius, so this would be the same normal force, the same material, all that stuff. However, that equation, right, mu times n, that's the maximum static friction. That's not what the static friction is necessarily, but that's the maximum static friction. So that's not how to think about it. Instead, think about it this way. We have the static friction force is going to be this way. Here's what you can think. So this thing is spinning clockwise, right? But when it gets to the top, it stops. That means the torque has to be pushing counterclockwise. What's doing that? That's the static friction force. The static friction is actually pushing uphill. And then you've got mg sine theta pulling downhill. So translationally, the bigger static friction force is going to make the object go higher up the hill. And which one is that? That's the ring. Right? And so that's what I kind of explain here, that friction force is directed uphill. So translationally, the ring makes it farther up. And so the ring must have a higher static friction force. And so that's what's indicated here with those symbols. The next thing they ask us to do is to find an expression for the static friction force uh, using using I and M and R, theta, and any other physical constants, like, for example, the acceleration due to gravity. Always start with a good force diagram. So here I have mg, the static friction force. I have a little triangle here so I can see where the angle is. This is mg sine theta pulling down. So I write out Newton's second law, sigma F equals ma. So the sum of the translational forces equals mass times acceleration. And it still works, right? Translationally, Newton's second law should still work. Putting in my forces, so I have the static friction force this way, and mg sine theta. So that's that component of the Earth force pulling down that way equals ma. The direction here is a little bit interesting. The acceleration, we say, well, that's downhill, so why would we put the negative in here? And the thing is, this a that we're going to put in, that we're going to substitute from over here, is the acceleration from the torque, right? And so, and it actually does end up working out. This is a negative thing that gets put in there, but also we have to check at the end, and I'll show you how that works out. We just want to check our signs, check our answers. So anyway, we have that, and then sigma tau, so the sum of the torques equals I alpha. Okay, what's the torque? R cross F. If we take the center of mass as the axis of rotation, then we have the friction force. That's what we want to find an expression for. So we substitute that in R cross F, but the order doesn't matter in this case because theta is 90 degrees, so sine of theta is 1. And then so I, instead of alpha, we substitute A over R. So A, now we substitute, or we solve for A, because this can then be plugged into this. Notice A is not one of the things that we can have in our final expression, so we're going to substitute that out, get rid of that. The rest of this now is just solving for Fs. So I bring the terms with Fs together on the same side. I factor out Fs, and then I divide, and I get this expression for the force of static friction. So let's think about this for a minute too. We want to check this out. I is on the bottom here, so it's mr squared over I. So if we have something like a disk as opposed to the ring, so a disk is 1/2 mr squared, has a smaller moment of inertia. And so we had said that that has a smaller um, coefficient, or smaller force of friction, right? So if we have 1/2 mr, so mr squared over 1/2 mr squared, this becomes 1/2 in the bottom. So this becomes 2. So 1 plus 2, that's bigger than what it would be otherwise. And so we have a bigger thing in the bottom. So the overall expression is less. So for a disk, we have a smaller static friction force than for a ring. And that's what we said, right? Disk is smaller than the ring. So that works. If we end up with a negative sign down here, playing around with the sign and trying to figure that out. I ended up with a negative sign. I ended up with 1 minus mr squared over I. Well, if you have a ring, then I is just mr squared. Mr squared over mr squared would be 1. And in that case, you have 1 plus, or 1 minus, if there's a minus sign there, 1 minus 1. That gives you 0 in the bottom of a fraction. And that's when the universe implodes, because you can't have 0 in the bottom of a fraction. And then you'll never find out what score you got, because the universe won't exist anymore. So best to make that a plus sign. C, so here they ask you to find, or to think about how the coefficient of kinetic friction would compare if, for example, they had some objects and they changed the surfaces so that there was slipping as they hit the ramp. And the answer there is that it would be the same for both. In this case, we do use the expression mu k mg cosine theta. Mg cosine theta gives us the normal force, and that's the same for both. It's the same angle, same mass. It's the same mu because it's the same material that they both have. And that means then that the force of kinetic friction is the same for both. So that's it. The challenge, of course, is figuring out this stuff about the direction of the torque, the direction of the static friction force, doing the solving, paying attention to those signs. But it should all work out. Pay attention and check your answers, compare them to one another as you go as well. So thanks for watching. Don't forget to like and subscribe.